Alright, so parts about any sort of membrane, that is the composition of it. And we've established that, so what are the different components of the membrane? What are the different entities within that membrane, like your sterols, your proteins, and what do different proteins look like within that membrane? And how are different proteins associated with the membrane. Now what we need to get into is actual movement across that membrane. So we're going to go through talking about not only some of the energy barriers and some of the energy aspects of transport across the membrane, but what does it look like in terms of the movement of different atoms. Okay, so the diffusion of a substance between two sides of the membrane resembles a bit of a chemical equation. So we have a source and we have a destination. You can almost think about that as reactants and products. So I think that's a helpful way to look at it because we are going to be talking about concentrations of a substance at the source and concentration on the destination side. Okay, the difference in the concentration of a substance on two sides of membranes generates a chemical potential difference, which that can all be summed up by delta G equals RT times the natural log of the concentration of the substance in the destination over the concentration of the substance in the source. So this is similar to products and reactants. Okay. Now the movement of ions across membrane also results in a charge difference, generating an electrical potential difference. So we have to think not only about how much of the substance is here versus here, but also what's the nature of that substance. So we're thinking about it in terms of charge, because when we talk about movement of substances across a membrane, we're generally talking about ions. So we have to take into consideration this electrical potential, which is going to be the charge of the ion, Z sub A, times Faraday's constant, times delta psi, your membrane potential unit in terms of volts. Now chances are that, well, I will always give you Faraday's constant, but what it is 96.485 kilojoule per volts per mole. But everything else will be just a part of the problem there, or will be, yeah, you'll have to know. So ultimately, what we have is an electrochemical potential that we have to solve for whenever we're talking about transporting something across membrane. So that is going to be delta G is equal to RT ln times concentration of our substance in the destination divided by the concentration of that substance in the source, plus, again, Z sub A times Faraday's constant times delta psi. Now, membrane potential is going to be A of that source times the destination. There's our electrochemical potential. Now, in general, that delta psi right there is going to be measured as the potential inside minus the potential outside of the cell. So inside is going to be the destination, outside is the source. So we're moving something basically from outside in. A negative number indicates the inside of the cell is more negative than outside of the cell. If an ion moves from the outside to the inside, then the membrane potential is just fine. So think about this right here as your default setting. You're moving something, and heck, here I'll go ahead and draw. I'll just say X ion going from the outside, the source, to the inside. I'm going to put a little positive charge by it, X plus that. I'm going to put a smiley face by it because this is your default setting. encounter that default setting, you don't really have to do anything in terms of the signs there. However, if an ion moves from the inside to the out, then the sign of the potential must be flipped. Okay, so you almost always are going to have the cytosol be considered the inside of the cell, or the inside of this. If more than one ion is transported, you have to calculate the free energy change for one ion, then multiply for additional ions. Okay, so what that's going to do is, as you transport ions, it's going to influence your charges there. So, question is, and we'll get to some examples in a moment, but just to kind of think about this sort of question, is it favorable for from a charge standpoint, to transport a Cl ion into a cell when delta psi is negative 60 millivolts? Okay, so these are all kind of laying out what this sort of problem is going to look like. And so, alternatively, is it going to be more favorable to transport it outward?